2.2, Solving Absolute Value Equations and Inequalities. Basically, we're going to look at a few examples using inequalities and traditional equations of the absolute value function. It's important to note the definition of absolute value to truly understand what you're doing here. The absolute value means how far or what the distance is away from zero some object is, or some number is. In this case, we're looking at an absolute value of 8 minus 4x equals 12. So what this really means is that whenever I plug this object in, whatever makes it true, this inside part has to be 12 or negative 12, because the absolute value of 12 is 12. The absolute value of negative 12 is also 12. So they're each 12 spaces away from 0. The way we handle this is by using two different cases. And so in the first case, I'm going to treat it as if the first object is positive. So we'll take off the absolute value, and I'll just work it out like a normal equation. So in this case, I would subtract 8 from both sides. That leaves me with negative 4x equals 4. And then I divide by negative 4 to give me negative 1. Case 2, I want to treat it as if the inside part is actually negative. So it would be negative whatever I plug in. And so I plug in, or I divide by negative 1 first to get rid of the negative sign, and then I would subtract my 8, then divide by negative 4, and I get 5. If I plug both numbers back into my original equation, it turns out that one gives me a negative 12 and one gives me positive 12, just as we thought it would before. Okay. Note the difference. This is simply removing the absolute value and working it out normally. Here I need to make sure that I add a negative sign to case 2. Notice the extra, it has just simply one extra step. I divide by negative 1 first. Now that's important later on when we look at inequalities. Being able or dividing by that negative 1 is going to be a reminder for something else. I know that you could simply make the 12 negative and the 12 positive and work it out and get the same exact thing. And absolutely, if it's an equal sign, you can go right ahead and do that. I want to get in the habit of dividing by negative 1 so that when I do have an inequality, I will remember to flip over my inequality symbol, and we'll get to that in just a minute. Let's do another example. Here's the second type of example that we're going to be looking at. Notice the difference. I've got 2x plus 6 all in the absolute value equal to a 4x. Notice this time I have an x outside of my absolute value. Now this is going to make a particularly special note, because if I ended up getting a negative result here, it's going to cause problems. Now we'll go through it and then we'll check our answers at the end. So case 1, just remove the absolute value, work it out. So I subtract 2x from both sides. 6 equals 2x, divide by 2, and I have a 3 equals x. Just as we did before, I place my negative sign out front, work it out just like normal. Divide by negative 1, and then I'll subtract my 2x again, and then divide by 6, and I get negative 1 here. Notice I've crossed this one out. If I were to take my results, 3 and negative 1, and plug them back into the equation, well, 3 works great. I actually plug it in here, and I get 2 times 3 is 6. 6 plus 6 is 12. The absolute value of 12 is equal to, well, 4 times 3, which is also 12. So 12 equals 12. Great, not a problem. But when I plug a negative 1 in, immediately I notice it's the absolute value of something equals negative 4. That's impossible. And that's something to note. If you ever see a negative on the outside, if it's equal, an absolute value is equal to a negative number, then that's going to be a no solution, or or it's not possible, or however you want to answer it. That's kind of a dead ringer. If you see a negative sign outside an absolute value, and this, like this situation does, you know that it's going to be no solution. But you can see it here. We plug it in, you get 4 equals negative 4. And of course, that's never true. So we call that an extraneous or an extra solution. It's presenting itself as real, but it is, in fact, not. The last example we're going to look at is using inequalities in absolute values. we have the absolute value of 2x minus 3 is less than or equal to 5. Now, the algebra isn't going to be any different. I'm going to work it out just the same, but I do have to notice to make sure I do one thing. Case 1, just like I would think, I remove my absolute value and I work it out. Add my 3, divide by 2, and I get x is less than or equal to 4. Divide by a negative number, or multiply it for any case, then I will have to flip my inequality over. And so when I do that, this 2x minus 3 is greater than negative 5. When used to be, it was less than symbol. So make sure, that's why I want to get in the habit of dividing by that negative number so that I remember to flip my inequality. Then I'll continue the problem just as like normal. So I'll add 3 to both sides, divide by 2, and I get x is greater than negative 1. Now this problem differs from the previous ones because our answer, we actually are going to create a number line, mark my critical values, and then decide if I shade outside the 2 points or will we shade inside. Now, if you get used to it, I can see here that x is less than 4, or less than or equal to 4, so I'm going to shade to the left. Here, x is greater than or equal to negative 1, so I shade to the right. It's pretty obvious to write that if you were to take these values and put them on the top of it, you'll notice that your actual arrow, the inequality, actually points in the direction that you need to shade. Okay, and we always leave the overlapping section if it's in between. If it's on the outsides, well, it'll just simply be shaded on both ends. Notice here that I plugged in 0 just to be sure, in case you're not positive. You can always pick a number from within the region and plug it back into the original equation and just see if it's true. In this case, we do 2 times 0 minus 3, which is negative 1. The absolute value of negative 1, that should be positive 1 here, not negative. The absolute value of negative 1 equals 1, so therefore your 5 is always greater than 1, so that's a true statement, so we would still shade in between the 0. Yeah, be careful, let me fix that real quick. Notice the inequality, or the numbers here have been filled in. We have an equal to portion underneath our inequality. It's not just greater than or just less than. So we notice that those are filled in. If they were simply greater than or less than, I would have had an open circle at my critical points. And that's really all there is to graphing an inequality equation and solving using absolute value, especially when we have an x on the outside to double check for extraneous roots. We're using case 1 and case 2 with absolute values.